All right, ladies and gentlemen, boys and girls, today we're going to do kind of part two of talking about osmosis, and we're going to talk about what happens because of the types of solutions cells are put into, and thus the amount of osmosis or the type of osmosis. All right, and so today is going to be very important to kind of remember a perspective and remembering a couple things. Number one, a solution is made up of a solute and a solvent. All right. Now, the solutions we're going to talk about when we talk about cells are primarily water. All right. Water is very, very important. And because when water goes in or out of the cell, and it's such an important thing, it changes the shape of the cell. Cells can swell up and cells can shrink because of the amount of solute going in, or solvent going in and out, the amount of water going in and out. All right. That process of water going in and out of the cell is what we call osmosis. All right. Osmosis. Osmosis is that diffusion, high to low concentration, no outside energy, of water. So, depending on what way it diffuses in or out is going to affect whether it all rushes in and swells up the cell, or the water rushes out and the cell shrinks down in size. And it depends on the type of it, or it depends on its surroundings. And so today what we're going to talk about is the different types of solutions that can cause different types of osmosis, or what cause a change in the shape of cells. All right. Now I have to preface it. What we are going to be talking about today is we're going to be talking about something called the types of solutions. All right. What we are doing this is in the type of solution that is surrounding the cell. All right. So I think every time we talk about this, as we go through, I'm going to emphasize it again. We're talking about what's going around the cell is going to affect whether water gets pulled out or rushes into the cell. So it depends on its surroundings to determine whether it rushes in or it gets pulled out. And that's what we're going to talk about today. Okay, so I'll give you a second to copy down this little chart. We got some cells. We're going to draw that. I'll give you a second to copy that down. Okay. Sorry, hopefully you paused and I actually copied that down. All right. So first one we're going to talk about is a solution where we have a lot of solute. All right. We're going to talk about a high solute solution. So the amount of solute, we're going to say high solute solution. All right. This is a high solute solution, which means this is the solution, the amount of solute outside the cell, which means if I'm going to use this as my solute, remember, two parts of the solution, there's going to be a lot of solute outside the cell here. I'm just going to draw there's a lot of sugar or amino acids or proteins or whatever we're talking about, ions, sodium ions, potassium ions. We have a lot of solute there. All right. High solute in this case, I know I'm writing a little small there. All right. High solute means in that solution means low solvent. All right? Which means if there's a higher concentration of solute on the outside than there is on the inside, that means we always are going to rush from high to low. So in this case, the water is going to rush to the lower concentration of water. Water is going to rush out of the cell. All right? Water is going to rush out of the cell. Well, think of a balloon. If you let all the air rush out of the balloon, what happens to the shape of that balloon? It gets smaller. All right? Cell shape is going to get smaller. The cell is going to, change marker. Sorry, I had a marker substitution. All right? Oops. That cell is going to get smaller. All right? It's going to shrivel. It's going to shrink in size. All right? This type of solution, where there's high solute on the outside, which causes the water to go out. Remember, it's high solute. That solute might be rushing into the cell. We're talking about osmosis here, the diffusion of water, that solvent. This is why, if it causes the cell to shrink, this is what we call a hypertonic solution. Hyper meaning high, Tonic means solution. So high solute solution means a hypertonic solution, which results in the shrinking of a cell. That is a hypertonic solution. All right. So now let's kind of think of the opposite of this one here. All right. Let's try a low solute solution. All right. Remember, this is going to be by comparison. So let's say inside my cell, I have a high amount of solute compared to outside my cell. This is a low solute solution. All right. What that's going to do, if this is out here on the outside is low solute, that means out here on the outside we have high solvent. All right. If we have high solvent on that solution, that means the water is going to go from high to low. In this case, the water is going to rush in. All right. Think of a balloon or a bubble. You rush in and blow in a bunch of air. What's going to happen to the size is that cell is going to swell. It's going to grow bigger. It's going to get larger in size. Ooh, I drew that really big. All right. Sorry. It's going to get bigger. Because this is a low solute solution, it caused the water to rush in. When the water rushes in, this type of solution here, that's on this outside here, again, talking about perspective, all right, is what we call a hypotonic solution. All right, the easy way for me to remember that, honestly, hypotonic has the big O in it. Hypotonic, you swell up. It's something silly to help you remember it, but I still literally use it today, is to remember that hypotonic solutions make it swell up. To swell up, that means it had to have water go into it, which means it had to have more water on the outside than on the inside because we are doing diffusion, high to low concentration. All right. Again, sounds kind of silly, but those are the little things that help you think about stuff and help you remember things. Remember that brain science. All right. Now, this last one here is, what if we have an equal amount? Now, this one is extremely hard to find because things are always changing. All right. Cells are always being put in environment. Their environment around them is constantly changing. But we do have a term for this last one here. If we have high solute, low solute, what about equal solute? 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, what if I have an equal concentration on both? All right. I think that the instinctive answer is nothing. The answer is wrong. The answer is going to be there's both, all right? Because it might not be equal on both sides. We are going to have both rushing in, an equal amount of rushing in, as we do of coming out or being pulled out. All right, we have an equal amount of water going in and out, and thus the cell size is going to stay, and leave myself a lot of space here, same. So this is not a hypotonic solution, it is not a hypertonic solution. This is prefix meaning the same, or the same in this case here, or equal. This is an isotonic. An isotonic solution. All right, this is an isotonic solution, meaning it's the same. All right, recap. First of all, remember it's about when we're defining hypertonic, hypotonic, and isotonic. What we're talking about is the solution outside the cell. Talking about the solution outside the cell. All right, so if the cell has high solutes, that means less water on the outside, the water is pulled out, it shrinks. If there is more solvent, more water on the outside, it's going to rush in and make it swell. All right. And there's the equal. It's going to be an equal amount of in and out. That's called isotonic. All right. Whew. All right. That's going to be it. Those are the three different types of solutions that cells are being placed into. And it just kind of depends on the circumstances. That depends if that solution, remember, we're defining it based on the solution outside the cell. Is that solution hypertonic, causing the cell to shrink? Is it hypotonic, causing the cell to swell? Or is it isotonic, where the cell stays the same size? Right? And a lot of times this changes all the time. It might swell a little bit, then shrink a little bit, and swell a little bit. The world around that cell and in that cell is constantly changing. All right. So biggest way to do this is just to practice and just go take your time. Slowly think about it. Sometimes it's easier to think across my chart from left to right. Okay, if I know this, I can figure out this and this. And sometimes, like I said, I remember hypotonic means it swells. So if it swells, I know hypotonic means it swells. If I know it swells, I can think about the direction the water had to flow to get there. And I have to think of it reverse. There's different ways to think about it. All right, otherwise, that's going to be it for right now. Good luck, and may the science be with you.